Superfox Education. Today I'm going to be doing a whole topic overview of C5, which is energy changes. So let's get straight into it. So the first part of energy changes is the actual type of energy reactions. Now there's two types of energy reactions. There is an endothermic reaction and an exothermic reaction. Now, if we start with endothermic means that it is getting colder. So if it's getting colder, it's losing. No, it's taking heat in. Whereas in an exothermic reaction, it's the opposite. It will be giving heat out. But there's a better way of saying it releases heat, it takes heat in. And that is it is taking energy in energy. Heat is a type of energy. So endothermic means energy is taken in. So there's an energy increase. Whereas exothermic means energy is given out. Overall, there's an energy decrease. So you may be asked to draw reaction profiles for these. Now, a reaction profile is just like a graph. And I'm going to do the one for endothermic first because I think it's the easiest. So here you're going to have progress or time. And here you're going to have your energy. Apologies for the writing, it's not easy to write with a mouse. And this is going to be the reactants here. R there. And if energy overall is taken in, then it's got to go like this because the product must be higher than the reactant if overall there's energy taken in. Now, you may be asked to label the activation energy and the overall energy change. Now this arrow at the top is the AR, activation AE, activation energy. And this arrow here that can go either way, the AR's got to be an arrow going up or down, not with two arrows like that. This is the overall energy change. So in the next part, we're going to be calculating overall energy change in bond energies. This will be the overall energy change. Energy change. I'm just going to put C change. However, for an exothermic reaction, you can probably guess it's exactly the same, but because it's an overall release in energy, the product should be lower than the reactant. And again, this is the activation energy, and that's the AE. I'm just going to put AE, you've actually got to label it activation energy in your exam, and from here to there will be the overall energy change. I'm just going to put OEC. That's overall energy change. And again, it'll be the same thing. Energy. That does not look like energy. And progress or time. Normally it's progress. I'm just going to put progress. There could be time. And this is a typical 3-mark question in the exam. Draw a reaction profile for exothermic reaction or endothermic, labelling it all. Now, also you need to know some examples of exothermic and endothermic reactions. So exothermic reactions, you could have exothermic reactions. So I'm going to draw this. So if I had a, what is this? Yes, burning. Burning is an example of an exothermic reaction. Also, you get neutralization reactions, displacement reactions. Many chemical reactions are exothermic reactions. So if you get a question in C4 saying it's a neutralization or a displacement, and you get asked about equilibrium, which is in topic 6, which I'll be doing very, very soon, it's always going to be releasing energy. Whereas endothermic reaction, taking energy in, such as electrolysis, that's the only example. Hand warmers. Another part of doing this topic is we need to calculate bond energies and overall energy changes. So here's an example here. Burning hydrogen in oxygen will give water. Calculate the overall energy change. This is a simple equation, and here's the bond energies. So we've got 2 lots of hydrogen. So we need to do 2 times 436, which gives us 872. And then we need to do 1 times oxygen, which is 498. That is, oxygen is double bonded. I know it only puts single there, but it's double bonded, not single. I made the mistake there. 498. Then what we do is we need to add those together because that's everything on the reactant side, which will be 1,200. Hold on, let's do this together. 0 plus 2 plus 8 is 0. Carry the 1. 7 plus 9 plus 1 is 10, 17. Carry the 1. 8 plus 4, that's 1,370. And then we need 2 H2O. So there's 2 times 2 of these. So we need 4 times 464. Because we need H2O times by 2. So that's 4 times that, which will be 1,000. Let me grab my calculator. 464 times 4 is 1,856. And then we're asked for the overall, so the overall energy change. Oh my god, I'm just going to do it as text because it'll be easier. Equals the reactants minus the product. So the overall energy change will be 1370 because that's of the reactants. That's of the reactants here. Minus 1856 because that's of the products here, which gives us minus 486. So the overall energy change is minus 4. Looks nothing like a 4. Minus 486 kJ per mole. Remember the units, and that's supposed to be a 6. 486 kilo, and because there's a negative sign here, because it's minus, we know that this reaction is releasing energy, meaning it's exothermic. So the next part is chemical fuel cells, and this is basically the opposite of electrolysis. And there's normally a question on this because it's the opposite of electrolysis. So electrolysis, we would have the cathode on this side, which is the negative, and the anode on this side, which is the positive electrode. Whereas chemical fuel cells, it is the opposite. So the anode will be on this side, the positive one, and the cathode will be on this side, the negative one. Hopefully I got that the right way round. Now, you may get asked to write a half equation. So, if I was to write a half equation, zinc 2 plus, because the zinc ions that will be produced at this electrode will be 2 plus ions, because this is the negative electrode, meaning positive ions will attract to it, plus 2e minus 2 electrons will give me zinc, the element zinc. And on this side, it will be Cu2 plus, because copper is a transition metal, plus 2e minus, will equal copper element. And this is chemical fuel cells. So just to summarize, this is the positive, this is the negative. So a way of remembering it is panic, positive anode, negative is cathode. Positive anode, negative is cathode. Panic. Way to remember it in your exam.